Lesson 5E is going to look at the quadratic formula and the discriminant. So the quadratic formula is another method that we can use to solve quadratic equations. All right, and we have two rules. It has to be in standard form, so that means ax squared plus bx plus c. So it has to go x squared, x constant, has to be equal to 0. Sometimes the problems you're given will already be in this form. Sometimes you have to move terms around to put them in this form. Okay, and then we use the quadratic formula. So here it is. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And we're just going to be plugging things in here. All right, so a is the term that is in front of the x squared. So for this case, it would be 3. So everywhere I see an a, I'm going to replace it with a 3. Okay, b is the term that is in front of the x, or the coefficient in front of the x. So this is a 3. All right, so everywhere that there is a b, I'm going to replace it with a 3. And then c, all right, is the constant term. So everywhere that there is a c, I'm going to replace it with a negative 126. All right, so let's go ahead and give this one a shot. So we have x equals, all right, negative b. So my b is 3, so this is going to be negative 3. Okay, and then we have plus or minus the square root of b squared. So that's 3 squared minus 4 times a, which is 3, times c, which is negative 126. All right, and then that whole thing is over 2 times a, which is 3 for this case. All right, so then what I want you to do is grab your calculator. And what I would do if I were you is put this string that is under the square root. So not the square root, but just 3 squared minus 4 times 3 times negative 126. Put that in your calculator exactly as you see it written right there, with the parentheses and all. Just type exactly what you see under the square root in your calculator. And if you do that, you should get 1,521 under there. And then I'm going to go ahead and simplify this. 2 times 3 I know is 6. Okay. Then what we see is if we can take the square root of this. So the square root of 1521 happens to be a whole number. It's a perfect square, which is perfect. It is 39. Okay, once I get to this part, now I'm going to split this apart into two separate equations. So I have x equals negative 3 plus 39 divided by 6, and then I also have x equals negative 3 minus 39 divided by 6 because it's plus or minus here. At this point, when you use your calculator, put parentheses around the top of the fraction to make sure your calculator does the addition or subtraction before it does the division. And what you should get there as your two answers is x equals 6 and x equals negative 7. Okay. Sometimes when we do quadratic formula problems, the number under the square root does not end up being a perfect square. Okay, and so when it does, we have to simplify the square root like we did back in September. So we'll look at one of these problems here. So remember, let's identify our variables. So a is going to be 8, b is going to be negative 12, and c is going to be negative 16. Okay, so x equals negative b. Well, negative 12 is positive 12, plus or minus the square root of b squared, and I'm going to put this in parentheses because it needs to be in parentheses in my calculator. Okay, so b squared minus 4 times a times c. All right, all of that is over 2 times a. Okay, so again, same thing here. Put this that is under the square root in your calculator exactly as it appears there. All right, and so you should get 656. So we have 12 plus or minus the square root of 656. Now, 656 is not a perfect square. Okay, so that means you have to use one of the two methods that we learned at the beginning of the year to simplify it. Okay, so you can either make a factor tree or you can simplify it with square roots. So I'm gonna come over here. So 656, okay, is equal to the square root of 16 times 41. So all I did was went through my list of perfect squares and figured out what I could divide 656 by. Okay, the square root of 16 is 4, and then 41 is as simplified as I can get. There's no other perfect squares that I can divide 41 by. So now I have 12 plus or minus 4 square root 41, because that is the square root of 656 simplified, all over 16. All right, and then the last step is to look at the things that are outside of the square root and see if they have a GCF. Okay, and 12, 16, and 4 can all be divided by 4. So I'm going to do that. I'm going to factor out of 4. So now I have 3 plus or minus the square root of 41 divided by 4. Okay, and we can leave our answer in this format. That is as simplified as we can get because I can't simplify that square root of 41 under the radical any further. Okay. All right, there is a piece of the quadratic formula that is special. It is called the discriminant. It is just that little part that's under the square root, b squared minus 4ac. And the discriminant tells you how many solutions a quadratic has. So if you remember, we talked about quadratics could have 2 solutions, okay, if they cross the x-axis in 2 separate places. They could have 1 solution if the vertex is on the x-axis. That one only has 1 solution. And they could have 0 solutions if they never cross the x-axis. Okay? And so that is what the discriminant tells us. So if the discriminant is greater than 0, then that graph is going to look something like this blue one. It's going to cross the x-axis in 2 places. If I do have a discriminant and I get 0, then there is 1 real solution. It only touches the x-axis in 1 place. And if my discriminant is less than 0, so that means any negative number, okay, so if I get a negative number for the discriminant, then there are 0 real solutions. Okay, so we'll do an example. Find the discriminant and the number of real solutions. Okay, so the discriminant is b squared minus 4ac. It's just what's under the square root. Okay, and it's still the same as when we do quadratic formula, a, b, c. Okay, so 10 squared minus 4 times 2 times 12. I'm going to do that math. All right, and I get 4. Okay, 4 is greater than 0. That's a positive number, so that means there are 2 real solutions. Okay, now 4 is not necessarily a solution, but the fact that 4 is a positive number tells me that there are 2 real solutions to this quadratic. All right, and that's it for 5e, guys.